Alright, so welcome to this video on Maths 305. So we are doing past question review considering Maths 305 2020-2021 exam question from the River State University, Port Harcourt, Nigeria. So this is question 6, and the question says, given that y of x is equal to 2 to the power of x, we're asked to find the y dx and calculate the sensitivity function of the first degree for x equals 0, 1, and 3. Hence, calculate the sensitivity function of the second degree for x equals 0, 1, and 3 as well. Okay, so that's the A part. The B part says, if the y dx is equal to 0.6 minus 0.01 y for y0 equals 40, calculate the steady state solution. Hence, determine the unique positive equilibrium value for the generalized ODE, the y dx equals a minus by to the power of 1.5 for y of 0 equals 40, provided the model parameter values a and b are positive constants. Alright, so let's start with the A part of the question. In the A part, we are given y of x to be equal to 2 to the power of x, and first of all we are asked to find the y dx and also to calculate the sensitivity value for x equals 0, 1, and 3. Alright, so from y equals 2 to the power of x, we need to first differentiate y with respect to x. Now, to do this, since I am having a constant raised to a variable, what I will do first is to take the natural logarithm of both sides. So this simply implies taking natural log of both sides. I will have ln y to be equal to ln 2 to the power of x, and you have this. Now, this simply implies that ln y is equal to, of course, from the principle of logarithm, if I have a number to a power, I will simply use the power to multiply the log itself. Now the power is x, so bringing down x, I will simply have x ln 2. Now I want to differentiate y with respect to x. The first derivative is going to be what? So this simply implies, since it is ln y, to differentiate this function, I will simply have 1 all over y dy all over the x is going to be equal to, this is now product of two functions, so I will keep x constant, differentiate ln 2. So holding x by product through constant, differentiate ln 2, that will give me 0 because 2 is a constant, plus now you hold ln 2 as a constant, differentiate x. If you differentiate x, you simply have 1. So this simply implies that 1 all over y dy all over the x is going to be equal to, of course, x times 0 becomes 0, and ln 2 times 1 remains ln 2. So I'll simply have ln 2. Now, I want to find the y dx, which means I'm going to be cross multiplying y. This simply implies that the y dx, is going to be equal to, if I cross multiply y, this becomes y ln 2. But it doesn't end there. Remember from the question, we are given that y is equal to 2 to the power of x. So this simply implies that the y dx is equal to, in place of y is 2 to the power of x multiplied by ln 2. So this is the first part of the question answered. The y dx is simply 2 to the power of x ln 2. Now this is the first degree, and we are asked to find sensitivity of the first degree function. So given the values x equals 0, 1, and 3. So given x equals 0, 1, 3, therefore sensitivity values. Okay, so first you find the y dx at x equals 0. So that simply means wherever you see x in the equation of the first degree derivative, put in the value as 0. This is going to be equal to 2 to the power of x, and x is 0 multiplied by ln 2. And 2 to the power of 0 is obviously 1. So which means the first sensitivity value simply means 1 times lane 2, which remains lane 2. So you can go ahead to evaluate lane 2 and obtain a value. Alright, second sensitivity value is when x is equal to 1. So you find the y all over the x at x equal to. Okay, so now we are considering when x is 1. Once again, not forgetting the y dx is 2 to the power of x, so that becomes 2 to the power of 1 times lane 2. And 2 to the power of 1 still remains 2 lane 2. You can still go ahead to evaluate this if you want to find 2 lane 2 and obtain a value. But I can keep my answer like that. So that becomes the sensitivity value at x equal to 1. Finally, we find the sensitivity value at x equal to 3, which means my dy dx value becomes 2 to the power of 3 lane 2. Okay, so we find dy dx at x equals 3. Okay, so at s equal to 3, my sensitivity value is going to be equal to, this is 2 to the power of x, and x is 3 multiplied by lane 2, and this is going to be equal to 2 to the power of 3 is 8 times lane 2. This becomes my sensitivity value. So this is for the first degree. Now the question also said that we should calculate the sensitivity value for the second degree. So that simply means recalling that my first degree, dy dx, which is my first derivative, simply gave me 2 to the power of x multiplied by lane 2. So which means I am going to be differentiating this function once again. Okay, now therefore the squared y all over the x squared, this becomes second degree. This is now product of two functions, 2 to the power of x multiplying lane 2. So from the principle of product rule, I will hold 2 to the power of x constant, differentiate lane 2. If I differentiate lane 2, of course 2 is a constant, that will give me 0 plus. Now you hold lane 2 and differentiate 2 to the power of x. Not forgetting we did derivative of 2 to the power of x earlier, and we obtained the result to be 2 to the power of x lane 2. So that means if we differentiate 2 to the power of x once more, it's still going to give us this derivative. So it becomes lane 2 multiplies 2 to the power of x times lane 2. You simply have this. So this is actually going to be equal to 2 to the power of x multiplied by 0 is equal to 0 plus. Now I have 2 to the power of x lane 2 times lane 2. So that simply gives us 2 to the power of x lane 2 all squared, because I have lane 2 multiplying I have lane 2 multiplying lane 2, so that gives us lane 2 squared. So this simply implies that the double derivative, let's simply use y prime prime for double derivative, is simply equal to 2 to the power of x lane 2 all squared. Okay, once again you can expand or find the equivalent value of lane 2 to the power of 2 and write it out instead. Now let's find the sensitivity values. Okay, all right, so we find the sensitivity values at x equals 0, 1 and 3. So y prime prime, when x is equal to 0, this is going to be equal to, wherever you see x, put in the value as 0. So I have 2 to the power of 0 lane 2 to the power of 2. Of course 2 to the power of 0 is 1, so the answer is simply going to be lane 2 all squared. So you can go ahead to also evaluate lane 2 squared to obtain a value, but I prefer to keep my answer like this. Next, you find y prime prime at x equal to 1. Okay, so after 0, we find sensitivity at x equal to 1. So this is going to be equal to 2 to the power of 1 multiply lane 2 all to the power of 2. So this is going to be equal to 2 to the power of 1 is 2. So I have 2 lane 2 all squared. So I have this to be my answer for that particular sensitivity value. Finally, I find y prime prime at x equal to 3. So I simply have 2 to the power of x, which means 2 to the power of 3 into lane 2 all squared. And this is going to be equal to 2 to the power of 3 is 8. So I have 8 into lane 2 all squared. So those are the values of sensitivity, or those are my sensitivity values. So that's it for the A part of that question 6. Now let's look into the B part of the question. Now the B part of that question says if the y dx equals 0.6 minus 0.00y, we are asked to calculate the steady state solution. Now at steady state, the y all over the x is equal to 0. So we simply equate this equation to 0 and find the value of y. Now, if you do that, you're going to have that 0.6 minus 0.01 is equal to 0. So this simply implies 0.6 is equal to, now let's send minus 0.01y over to this side, not forgetting there is y here, over to this side of the equation. So that becomes 0.01y. Now we simply make y the subject of the formula. This simply implies that y is equal to 0.6 divided 0.01. Therefore, y is going to be equal to 60, and this becomes the solution of that equation under steady state condition. All right, guys, so that's it for that given question. This is another question on sensitivity. So the question simply says, given that yx is equal to n to the power of 4x multiplies n to the power of negative x. For n equal to 0, you're asked to find the first degree of sensitivity for n equals 4, x equals 0.167. Okay, so we have that our function yx is simply equal to, we're given n to the power of 4x multiplying by n to the power of negative x. Now, from indices, of course, when two terms having the same base are multiplying one another, you simply pick one of the base and add the powers. So this simply implies that my y is going to be equal to, I have n to the power of 4x, okay, then adding this, now it becomes minus x. So this simply implies that y of x is equal to n to the power of 4x minus x gives us 3x. Now you're being told for n is equal to 4, x is equal to this. Now before you find sensitivity, it means you have to first of all differentiate. So this simply implies that y4 yx is equal to n to the power of 3x, and n now is simply 4. So I have 4 to the power of 3x. So this is now, I have y to be a constant raised to a variable. So in order to be able to differentiate this, I have to first of all take the logarithm of both sides. Okay. So that means I'm going to be considering the natural logarithm of both sides. Hence, I will have that ln y is equal to ln 4 to the power of 3x. So from the principle of logarithm, whenever the log of a number is raised to a power, you simply use that power to multiply the log itself. So this simply implies that ln y is equal to, this becomes 3x ln 4. All right, so we need to now differentiate y, okay, with respect to x. So differentiating y with respect to x, remember since I have ln y, so each derivative becomes 1 all over y dy all over the x, and that's equal to, this is now product of two functions, 3x multiplying ln 4. So from the rule of logarithm, hold 3x as a constant, differentiate ln 4. If I differentiate ln 4, I'm simply going to have 0 since 4 is a constant, plus, now you hold ln 4, differentiate 3x. If I differentiate 3x, I will simply have what? 3. So this simply implies that 1 all over y dy all over the x is going to be equal to 3x times 0 is 0. Now I have 3 multiplies ln 4. So this is simply 3 ln 4. Okay, now I need to find the y dx, which means I'm going to be cross multiplying y. Y multiplies everything here, and this simply implies that the y all over the x is going to be equal to, this is now y multiplying here becomes 3y ln 4. But not forgetting from the question, we were given that y is equal to 4 to the power of 3x. So in place of y here, we put in the value 4 to the power of 3x. So this simply implies This simply implies that my dy all over the x is going to be equal to, this becomes 3 times 4 to the power of 3x ln 4, and we have this. Okay, now therefore the sensitivity value, remember from the question, you were told that when n is equal to 4, x is equal to 0.167. So you find sensitivity when x is 0.167, since we've considered when n is 4. Alright, so dy dx, therefore dy dx at x equals 0.167 is now going to be equal to, wherever you see x in this derivative, put in the value as 0.167. That becomes the sensitivity value of that function. So you have 3 times 4 to the power of 3x, but x is 0.167 multiplying ln 4. So this is going to be equal to, now this is 3 times 4 to the power of, let's obtain 3 multiplied 0.167. That gives us 0.501 multiplies ln 4. This is equal to 3 times, let's find 4 to the power of 0.501. That gives us approximately 2 ln 4. So this implies that the sensitivity value dy all over the x at x equals 0.167 is equal to 3 times 2 gives us 6 multiplied by ln 2. So you can go ahead to evaluate ln 2 and obtain a value, but then that becomes the final answer. Alright, that's it for that given question. I will see you in the next video with another question on Master Your 5 past question review. Thanks and cheers.